So let's spend some time going through 1.2 homework. I think that's really all that I have. I knew that I was going to need graph paper for 32 and 26, so that's why I did that. But I'll come back to those. So they're just there. I have graph paper. No, you must endure all of the boring stuff also. Okay, so do we start at, what did we start at, 14? Of course I knew that. Okay, so hello. So did you subtract correctly? 6 minus negative 2 and negative 2 minus 2, question mark? Did you?
I got negative 2.
8 over negative 4. Happens to the best of us. Next, which one do we go to next? There we go. I knew that. All right. So now, number 14, it says just find the slope and y-intercept. So we talked about this. Remember, somebody answered yesterday, get y by itself. Well, that's all you have to do on this problem is get y by itself. It's just that these answers aren't so friendly, yeah? So divide, and so the slope is negative 1/3, and the y-intercept is 7/9. Okay, that was easy. Those two problems together took less than a minute, and I'm even writing awesome.
Number 18.
Here we go.
I didn't feel like A, B is this, AC is this, and A, B.
What is she chitter-chattering about?
Never mind, just keep going.
Okay. Number 18. It's 3y equals 5x minus 5, yeah? Oh my gosh, it's the same thing, only easier. 5/3 x minus 5/3. This is the slope. This is the y-intercept. Why they picked the letter B for that, I don't know.
I know you didn't have to know the y-intercept.
What are we supposed to do? I was just seeing if you guys were paying attention.
But that's what you do. You just get them.
Dang it.
You could, yeah. No, you're good.
There we go. Obviously, I was showing you what we did from the previous problem because it's related to this problem.
Yeah, obviously.
Okay, so then there's a B equation, but the B, so this was A, but then there's a B equation that looks like it's already in slope-intercept form. I need to probably read the directions. Tell which ones have parallel and which ones have perpendicular. Okay, obviously these two dudes are perpendicular, right? A is perpendicular to B. So far, that's cool, right? Okay, then there's an equation C here, and C is 10y equals negative 6x minus 7. Divide, that's what? Negative 3/5 x minus 7/10, but I don't care about the 7/10. So then that means that A is perpendicular to C, right? A is perpendicular to C. And then the last conclusion we can draw is that B is parallel to C. Ta-da!
21.
Any questions there? Okay, okay. 21. Find the value of k if the line joining blah and the line joining blah and blah are parallel and perpendicular. So the first thing I want to mess around with is the negative 1, 4 to 0, 8, because that guy's locked in. So that slope is going to be 4 minus 8 and negative 1 minus 0. So that's what? Negative 4 over negative 1, which is just 4. Would you agree with that?
Yes.
Okay, so that means for parallel, and actually I could write it as 4 over 1. Does that bother you? It kind of bothers me a little. Okay, so now I have the original points, which were 4k and 6, 8. So then I'm going to say that k minus 8 over 4 minus 6 has to equal 4 over 1 for them to be parallel. And k minus 8 over 4 minus 6 has to equal negative 1/4. Maybe one of you guys forgot the negative symbol on that part. For it to be perpendicular, yeah? Yeah, okay. So here goes the work. So it's going to be k minus 8 on the left. I just multiplied here, right? And then I'm going to multiply negative 2 times 4 there and get negative 8. And then I'm going to add 8 and get 0. So the value of k that makes them parallel is 0. Okay. Now for the perpendicular part, by the way, my work here is looking perfect. I'm going to cross multiply again, but this time that 4 is going to get distributed, and it's going to be 4k minus 32 equals negative 2 times negative 1, which is 2. Oh, did we do this problem yesterday? Something very close to it. All right, so 4k equals 34. Dang it. What is that, 8.5? Whatever. Somebody looked at the answer in the back of the book. Really, you just wrote it as 17 over 2. I think you're the only teenager that would.
Okay.
Show of hands, 17 over 2. You better raise your hand. Wait, well, she's from a different country. JK. But she is. Number 25. I was waiting on Tom Leonovich, but slacker. Number 25. Show that the points blah, 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 and blah are the vertices of an isosceles trapezoid. Oh, snap. Is this one that I... Dang. Okay. 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 I'm not freaking out. I am not freaking out. I'm going to go here. I hope. I'm going to go here. Wait, no, I'm going to go here. I'm going to look for graph. Searching, searching, searching. Pictures. Ha! Come on now. Now watch it. Probably isn't big enough graph. It doesn't. I know it. Well, okay. 4 left, 5 down. 1, 2, 3, 4. 1, 2, 3, 4, 5. That was weird. I was going left and down, but I was counting up the tone. 3 left, 0. 1, 2, 3. 0 across, 2 up. Ooh, I was not expecting that point. Were you? And 5 to the right. 1, 2, 3, 4, 5, and 1 up. Okay, so if I were to connect choo-choo and connect choo-choo and connect choo-choo and connect. No, you will not do that.
No, I don't like that
Somebody may have just failed my class. Okay, so here's the deal. An isosceles trapezoid has congruent legs and it has parallel bases. So it's got to have congruent legs and parallel bases. Base 1, and base 2. How do you find the area of a trapezoid? 1/2 the height, parenthesis, B1 plus B2, but that has nothing to do with this. How am I going to prove that those legs are congruent? Nope. I want to do this part first. I want to do part A. Oh, I want to do part A first, and then I'm going to do part B second. So how do I show that those two legs are congruent? What? Distance formula. I'm going to show that they're equidistant. No, well, equal distance. I'm going to show that they're the same length. Ready? So can I call this, what letters do you want to start with? L, M, N, O. No, I don't want that. P, Q, R, and S. Okay, so first off, I'm going to show that PQ is congruent to SR. Ooh, it's like geometry class. We could bust out some CPCTC. Yeah, you know me. We could throw out some, we're going to do some geometry stuff in this class. It's pretty cool. Don't you worry. Alternate interior, coming back. Okay, here goes. So I'm going to find the length of PQ or QP. It doesn't matter which way I list it. And those must have been the first two dots that I listed here, y'all. Y'all. Okay, so that's going to be, and then, so I have freshman algebra first hour. And so today we were talking about PEMDAS. Please excuse my dear Aunt Sally, which is the thing that I've learned since, I don't know, 6th grade, 4th grade. I don't know what grade I learned it. But, and I thought, that's the dumbest sentence. Please excuse my dear Aunt Sally. Like, what is that? So one of my students said, how about, please eat my donuts and Skittles? I'm offering you donuts and Skittles at the same time.
Skittles on donuts.
Right. Skittles on donuts.
Get a little crunch to it, but it's still.
Yeah, and a little fruity flavor with your, I don't know, that might be kind of gross. Probably just glaze, something boring. Yeah. Okay, so here goes QP. It's going to be now, since we've been doing slope, I almost wrote the Y stuff first. But it wouldn't matter. It wouldn't matter on this because they're getting added together anyway. So I'm going to do the X. So it's going to be -4 minus -3. And then it's going to be 5, sorry, -5 minus 0. Yeah? Yeah. Okay, so that's going to be -4 plus 3, which is -1 squared. And this is going to be -5 squared. And so that's 1 plus 25, which is square root of 26. I don't care what that is. 5.1. Now I got to find the length of RS. So RS is here, and here, and here, and here, and here, and here, and there. So now RS must be the other two. So that's going to be 0 minus 5, yay. That's going to give me the 25. And then 2 minus 1. Yeah, that's going to give me the 1. So this is 25 plus 1, which is the square root of 26. Okay, part A, check mark. Got it. Done. Now for parallel bases. How do I do parallel bases? So I do parallel bases. What do I have to show? They have the same slope. So now I pretty much have to show that the slope of QR is parallel to the slope of PS. And if that's the case, I have proven what I was supposed to prove. So QR, those are the second and third points. Here we go. So now I got to put Y's on top. So I'm going to do QR, the slope of QR. So it's going to be 0 minus 2, and -3 minus 0. Well, that's 2/3. And then I'm going to do the slope of PS. And the slope of PS, that would be the first and the last, y'all. So it'd be -4. Whoa, almost messed up. -5 minus 1. Uh-oh. And negative 4 minus 5. Please tell me this works. Please tell me this works. What is negative 6 over negative 9? Oh, no, I messed up. But no, I did not. That simplifies to 2/3. So that's the slope there, and that's the slope there. Did we show that the bases were parallel and the legs were congruent? Yippee skippy. Fun fact, the diagonals of that isosceles trapezoid are also congruent. Fun fact, the two upper angles are congruent and the two bottom base angles are congruent. Fun fact, this is supplementary to that. The measure of Q is the measure of angle Q is supplementary to the measure of angle P. Thus, the measure of angle R is supplementary to the measure of angle S. Because of course everybody knows that the sum of the interior angles of that quadrilateral has to add up to 360. Because you obviously used the formula that you memorized, n minus 2 times 180.
Sure.
Flashback to geometry. It's just a plethora of information. You just have to open, in your brain, you have a math toolbox. You just got to know what drawers to pull on. You can't just reach for every drawer hoping you find something.
It's too full, my brain starts throwing up old stuff.
Oh, I got one of the big Craftsman math toolboxes. Like, you know, the ones with all the drawers and the big drawers. But I have my drawers labeled at least.
And like a little pencil bag.
Yours is a pencil bag with a combo lock on it. Do you have like a combination lock on it?
Yeah, I know. I forgot the.
And you forgot the combination? Aye, aye, aye. Are we ready to move on? Wow. Okay, so had I given you this problem before and I said, prove that these guys form an isosceles trapezoid by showing that the bases are parallel and the legs are congruent, then I think you would have got it, right? But if you didn't remember the geometry properties like that. But now that I've showed it to you, I think you could repeat it on a quiz. I don't know, maybe. Haven't made the quiz yet.
Are you gonna say that these things are going to? No.
No, because I just said it to you. And I said it to our online listeners. She replied to my comment. Remember when I said if she doesn't reply, then she's on the team, something like that. She goes, no, I'm replying, no, something like that. That was when I was trying to figure out how to get the wrong size SIM card into my new phone. Now do we go to 26? Oh boy. There we go. What is so hard about 26?
So that you just do like these ones are parallel and then the other ones.
Okay. I would, like on a quiz, I would probably, this is a really mean problem. Because for it to be a rhombus is a slanted square. Okay? And so for it to be a square, all the sides have to be congruent. And for it to be a square, all of like the top's parallel to the bottom and the left's parallel to the right. Did anybody do all 8 things?
I did the parallel, but I forgot about
Okay. So for time's sake, did you get, this should have been a positive slope here. What was that slope? Do you have a positive slope somewhere?
I either have a half or 211.
This, oh wait, this is 1/2, right? And so is this one. And then you're saying that the other one is 2/11?
Hold on, I messed up somewhere.
The other two slopes are 2/11.
Yeah, 2 of them.
This is 2/11. Is this 2/11? And is this 2/11? Okay. By golly, that would be really, really mean to do 4 distance equations like on a quiz. Like on a quiz, wouldn't that be really, really mean
Yeah.
to have you do? Because really, you've shown me that you can do slope, and you've shown me already that you can do distance. This would be 8 problems altogether. So so on a quiz, I wouldn't throw this one at you. Time consuming. But did you get the distance from, let's see, from here to there to be the square root of 25? No? Of 125?
I just forgot to, I just got 5 squares.
Okay, so let's do one of them, and then we're going to be done. So I'm just going to go from here to there. It's going to be -1 minus 10, which is 100, and then -1 minus 4, which is 25. Okay, so that's the square root of 125. Everybody knows that that's 5 times 5 times 5. So then that means that all 4 distances equal 5 root 5. A rather mean problem. Not a quiz question.
What's the area on
Why?
the
Oh my goodness. Really? Okay. The area of a rhombus is 1/2 d1 times d2. I'm sure that you looked that up on Google. Hey Siri, what is the equation for the area of a rhombus?
Seriously, let me down. Try again.
Last time she was trying to make it read Wikipedia.
Last hour she would not spell parentheses for me. Did you know that there's a parenthesis, IS, and a parentheses, ES? The IS is when you're just talking about like one side. Yeah, and parentheses is ES. I know, but she didn't share that with me either. But she'll tell me a joke.
Ask for a joke.
Hey Siri. Hey Siri. Hey Siri. Tell me a joke. Oh, I just realized I'm yelling into the microphone also. Sorry, online listeners. Okay.
I just wrote what you were like in below it.
Oh my goodness. Okay, I'm going to do it because, yeah, we need to do this learning experience. Here we go. I'm going to call the long diagonal D1, okay? So the long diagonal is going to have a distance like this. It's going to be, so I'm going from here to here because those points aren't listed. So it's going to be -1 minus 20. Oh, great. And -1 minus 6. That's cool. I'm cool with that. So that's 21 squared, and that's 7 squared. Oh, Mr. Blanchard, don't you mean -21 and -7? Does it matter?
So what is this for? The area?
Oh, yeah. Heck yeah, because somebody pointed that out to us.
Why do you have the little like square root thing you went over the square root and like formula?
Because we got to find the distance for each one of these puppies. I know. That means diagonal. So the length of diagonal 1. So I'm calling the length of diagonal 1, I'm calling that the longer one. So
The area of the rhombus.
Somebody apparently I didn't read my book problem. So 21 times 21, 400, 400 and what? 40, what, 441? Yeah. We're going to go with that because I got a nod of a head. And that's 49. And so that's the square root of 490. But that's going to be what? 7 square root of 10? That doesn't look right at all, but okay, let's keep going. Now we have to find the length of diagonal 2. So diagonal 2 is the short one. Are we sure that this was one of the questions? Hey, can you find the 9 minus 10 squared and 4 minus 1 squared? That's negative 1 squared, which is 1. That's 3 squared, which is 9. That's the square root of 10. Oh, okay. I'm feeling a little better about this problem now. Now the area of the rhombus is 1/2 d1. I'm going d1 times d2. Really? Interesting. So that's 1/2 of 7. Wow, that's acting weird. Did you see that? 7 square root of 100. But 7 square root of 100 is 7 times 10. So this is 1/2 of 70, which is 35. Sure. No. What number is this? Oh, I did it right. This was a huge, oh, no, there isn't. These are lengths of sides, okay? Even though you're thinking they're slanted, so you might, I think you're misinterpreting the word diagonal. Those are just sides. These, hang on, let me do it. It's okay. It's all right. These are the 2 diagonals, long one and short one. Good question. I pretty much got technology. Just saying. How long would that have taken the average teacher? Square units, I don't know what it was supposed to be. My book doesn't even, my book just says 35. How's your patience level? Like,
I'm excited.
good. Not worried, excited.
Yeah.
She's worried.
Sure. Okay, here we go. I'm going to go there, but I'm going to add a slide because I'm sure 32 is just as easy as all the other ones. Oh, snap, it isn't. Okay. Okay. Because I want to challenge you. You're missing the point. Can I please explain what the point is?
Point is to learn in your homework.
Here's the thing. Here's the thing, especially about math class. You're going to have so much confidence. It doesn't matter what we're learning. You're building your own confidence that later on in life that you can recall back to, hey, I survived through pre-calc. Hey, I survived through calc. I survived through differential equations, whatever. You'll have that confidence so that when your boss comes up to you and says, hey, we just bought a new program and you got to learn it, then you don't freak out. You say, okay, I'll learn it because I've learned. Confidence. So like English class, there's a little creativity there, but you still have rules to follow, but it's a little different. Math is very structured, isn't it? You don't get a lot of freedom with math. Sorry. But you like us doing these challenging problems, it's just to build up your confidence. Because even though you may not know how to do this problem yet, once I do it, then you're going to be like, psh. And that's how it is pretty much at life. Like once you figure out how to do something, even though you thought it was challenging, later on you're going to think, psh, piece of cake. There, I'll step off of my soapbox. But I couldn't even climb up onto it because my hip's broken. Well, I'm pretty tough, so it might be broken. But I have a feeling when I was getting out of my car that I really think something's just pinched like in there. I think it's nothing that Aleve or naproxen won't take care of. Okay, watch me do this. This is a cheat, I know. Oh, I don't want that one though. Okay, here's the idea. Wait. Here's the idea for this problem. This is one side of a square. You with me? Okay, now let's see. Please tell me this works. I hope this works. Like my whole plan was for this to work. Okay, so now I'm going to show you what the goal is. And I think in the process, I might actually show you the answers. Here's a square. Please work, please work. Dang it, it didn't work. How do I make it go? I don't want that. I don't want that. I want it to be, I know I got to. I got to go to my select tool. And I want to go there. And then I want to make sure that it's parallel. And then I want to make sure that this guy, oh, that's not cool. Okay, there. And then I want to do that. This is kind of hard to do with this. Okay, so, hey, look at that, everybody. There's a square, kind of. And your goal is to find this spot up here and that spot over there. But wait, I could have also made the square here, right? And your goal is to find that dot there and that dot there. But now, that's a great question. It has to be that piece right there. Okay, so now if I go here and if I copy this, again, I'm using technology that you couldn't do. But if I copy that, where's it at? Oh, no, sorry, I want to clone it.
Wow, mister.
I want to clone it. What's infinite cloner? Do you dare me to? Where's it at? Oh, all right. Okay. So here's a piece of the square. And this is just for demonstration purposes and only. Oh, this is going to mess up the length of the square. But, sorry. Dang it. But not only do I have to have the right length, but this also has to make a right angle, yeah? That also has to make a right angle. Would you agree? So, to find the correct distance, to find the correct length, I have to use the distance formula. Agree? To find the correct right angle stuff, I have to know what the slope of this line is. I don't know. Okay, so are we ready to start the problem now? Here we go. Go away, infinite cloner. So I use graph paper because I can cheat. 2, 4, 6, 8, 2, 4, 6. This slope is rise 8, run 6. Would you agree with that? Hey, Mr. Blanchard, how come we didn't reduce that? Say it. Hey. Because if I don't reduce it, I can cheat on graph paper to get all my right points, all my correct points. Okay, what would the slope, hang on, I'm going to mess up our drawing. What would the slope of that line right there have to be? Nope. What would the slope have to be? Negative 6 over 8. Okay, so I want to start here, and I want a slope. Whoa, you see that? That's why I don't write cursive. I want a slope of negative 6/8. Now, normally, that would mean down 6 and right 8. Would you agree with that? Normally, that would mean down 6 and right 8, but I want to put the dot over here somewhere. So instead of negative 6 over 8, I want it to be 6 over negative 8. Did I lose you?
Yes.
Would you agree that these two slopes are still opposite reciprocal? Yeah, okay. So now I'm going to go rise over run, but it says for me to go up 6, 2, 4, 6, and now I have to go to the left 8, 2, 4, 6, 8. And that is my third point. So my third point is what? 2 to the left, so negative 2, and then 2, 4, 6, 8, 10, 12, 14. Is that right? Did I count right? It doesn't look like 14, does it? 2, 4, 6, 8, 10, 12, 14. Up. Okay. Do you get that? Okay. So could I now draw this line? And magically, I do not have to worry about the distance of that segment, because when I didn't reduce this, that took care of it. So I don't even care what the length is. I don't have to use the distance formula. All right, so now for your only homework today is to finish this. So you're going to have a fourth dot somewhere over here. Yeah. Oh, hang on. So you're gonna have to find the fourth point. There's gonna be a fourth point there somewhere. You're gonna have to find the fifth point, which is going to be somewhere down here, and you're going to find the sixth point, which is going to be somewhere over here. Okay? So I want you to find those 3 red dots. Are you ready, red? Like this one is so, this one over here is so easy.
So it'd probably be
Because this guy is the length, and it's got to be that. So what does the slope have to be of this guy? 6 over negative 8. So now you're going to be able to find that position of that dot so easy. Do you get it? Now try to get the fifth and sixth points. That's all I'm going to say. That's your only homework. Find the 3 red dots. Ta-da! No new notes. No new nothing. Just those problems right there. Sorry, Kylie, about, oh, sorry, and I always forget about Taylor. I'm sorry, Taylor. I'll give you extra credit or something because I haven't said her name in class. Stopping that